Hello everyone, and thank you for joining this session on getting started with Dart on the server with Serverpod. My name is Victor, and I'm the founder and lead developer of Serverpod. Today, I'm going to talk about Serverpod and using Dart on the backend. I will share insights from my experiences, hoping to inspire you to take the first steps in building your own server. Let's dive in. Before we dig into the details of how Serverpod works, let's quickly look at how backend servers are generally set up. First, we need somewhere to store our data. The data is stored in some sort of a database. If you're not using a serverless architecture, this is most often a relational database. In Serverpod, we use PostgreSQL, which is the most widely used relational database for app servers. Imagine your computer's spreadsheet application on steroids. This is what a relational database is like. A table in the database is like a spreadsheet filled with data. Each column in the table represents a data type, like a string, an email address, a number, or a date. A row represents an entry or an object. So far, things are similar to a regular spreadsheet, but the real power of the database is in how you can connect the tables. For instance, this allows us to have one table for customers and one for their orders. By using keys and relations, we can link each order to a specific customer. This is what we call a one-to-many relation. One customer can have many orders. Another large difference from a spreadsheet is the ability to quickly search for data in the database. You do this with queries. You can index the data for queries you do often, so it's very fast to search. These queries are made with SQL, which stands for Structured Query Language. Different databases have different dialects of SQL, but the basics are the same. The objects you store in the database are referred to as models. A model defines the types of a database record or a row. It maps the columns to the fields in the model object. This system is called an object relation mapping, or an ORM for short. The ORM can also help you with writing your SQL queries. In Serverpod, our ORM is also type safe and null safe, which means that you can get great editor support, including autocomplete. Next, we need our app users to be able to access the data in the database. Theoretically, we could expose the database to the world and have our users read and write to it directly. In some solutions, you actually do this, but it comes at the expense of many limitations and security considerations. For instance, if you update your models, all apps that access the database must be updated. Instead, creating an API server between the database and the app or client is better. This allows you to change the underlying database without losing compatibility with old apps that your users may have installed. It also allows you to process the data before sending it to the app. Accessing the database is also an expensive operation, and by using an API server, you can cache common requests in memory, both making it blazing fast and cutting down on costs for hosting. The API server is basically just an app running on a computer with access to the internet. It will listen to connections from clients and return data. In some cases, the server can also keep connections open for a longer time to make it possible to push data to the client. This is often done using WebSockets. For instance, if you have a chat app, you will want to pass messages to and from the server in real time. The most common way to communicate between the client and the server is using HTTP and passing JSON objects, which is often referred to as a REST API. To build a server API, a few things need to be in place. First, we need a way to encode and send our objects. This is called serialization. We take an object in the server's or client's memory and create a textual representation of it. Next, we need to be able to call different methods on the server. On the server, you create endpoints that group methods together logically. The method is a URL that we can call from the client, just like we would type a URL in the browser's address field. If you are building a larger application, having a single server may not be enough, as there is a limit to how many requests it can handle. In this case, we may want to create a cluster of servers and placing them behind a load balancer. The load balancer will distribute the requests between the servers. An added benefit is that the API will still be available if one of the servers crashes. To summarize, this is what a simple backend architecture can look like. At the front, we have a load balancer that receives requests and passes them on to the API server. The servers fetch data from the cache and the database, then format it and send it back to the client. Luckily, ServerPod handles all these tasks for us, so we don't need to dig into all the technical details. Knowing a bit more about what's happening under the hood is still a good idea, and it will take you a long way. Now that you know the basics, we will look at what you can do with ServerPod. After that, we will dig into how you set things up. And a spoiler alert here, despite all the features of ServerPod, it's really simple to work with. ServerPod is an open source, scalable app server written in Dart for the Flutter community. It has gained a lot of traction among Flutter developers since its initial stable release just a year ago. We now have over 5,000 ServerPod developers. The framework comes with many features that make it faster to get things done, debug your code, and deploy your server. It automatically generates your protocol and client-side code by analyzing your server. Calling a remote endpoint is as easy as making a local method call. And of course, best of all, you can write your entire backend in Dart and even share code between your app and server. ServerPod really is a complete, competent backend for Flutter. Apart from being just a server, ServerPod provides solutions to many common tasks that are otherwise cumbersome to implement or require external services. It provides you with world-class logging capabilities. You no longer need to search through endless server logs. Instead, you pinpoint exceptions and slow database queries in an easy-to-use user interface with just a single click. You get the high-performance distributed cache built right in. Any data models can be cached locally on your server or using Redis if you need to use the same cache as a cluster of servers. ServerPod also gives you the ability to communicate easily with your database. With ServerPod's Object Relation Mapping, or ORM, your queries use native Dart types and null safety. The database layer even has support for things like database migrations and relations. In addition to these features, ServerPod has support for everything you would expect from a modern backend framework. Firstly, ServerPod simplifies the task of handling file uploads. You can connect it directly to Google Cloud Storage or S3, or you can even store files within your database, which is great for local development. When it comes to authentication, ServerPod takes care of all the tricky parts. You can integrate social logins into your application with support for services like Google, Apple, and Firebase. You can, of course, also do traditional email-based sign-in. If you use Google, you can get access to all server-side APIs like calendars and contacts. A standout feature of ServerPod is its support for streaming data. This means you can pass models and push messages from your server, enabling real-time interactions with your app. Whether you're building games, chat applications, or any other service that benefits from instant data exchange, ServerPod has you covered. Moreover, it supports sending messages across a cluster of servers, ensuring scalability and reliability. ServerPod reimagines task scheduling with its future calls feature. This replaces the need for complicated cron jobs by allowing you to call a method at any specified future time or after delay. These calls persist even after a server restart, ensuring that your scheduled tasks are never missed. Say you have a user signing up and you want to send them a reminder a week from now. Just make a future call. Monitoring the health of your application is crucial, and ServerPod provides comprehensive tools for this purpose. You can monitor not just the database, CPU, and memory usage, but also any external services your application relies on. Lastly, deploying your server with ServerPod is a breeze, thanks to the provided Terraform scripts for Google Cloud Platform and AWS. These scripts facilitate a quick and seamless deployment process, allowing you to focus more on development and less on the complexities of server management. ServerPod comes with a companion app called ServerPod Insights. It allows you to access your server's logs and health metrics. A common problem with servers being slow is that there may be database queries that aren't quite optimized. Traditionally, this can be very hard to track down. I don't know if any of you have experienced this, but it often involves downloading large log files, running them through custom tools, and then digging through your code to find where the slow queries were made. It's painful, to say the least, and can take hours. But with Insights, you can set it up to automatically log any slow method calls or queries. With a single click, it takes you right back to the line in your server's code where you made a query. You can even change the logging settings of the server while it's running, enabling detailed logs for specific methods. Okay, so that's a lot of features. Luckily, it's really easy to get started. When you start out, there are only a few things that you need to know, but all the other stuff is there, ready to use when you need it. Pretty cool. First, let's start looking at installing ServerPod. You will, of course, need to have Flutter and Dart installed, but you will also need Docker. Technically, you can run ServerPod without Docker, but it makes things so much easier to have it. When running Docker locally, we use Docker to host a Postgres database for you. Great, we have Flutter and Docker installed. All we need to do now is to install the ServerPod tooling. Do this by running dart pub global activate serverpod_CLI. To double check that everything is installed correctly, test drive the installation by typing serverpod in the terminal. If everything is correctly configured, the help for the serverpod command will be displayed. That's it. You're officially ready to explore the wonderful world of serverpod development. Before we start building, we need to create a new project and get our ServerPod up and running on our local computer. Open up your terminal and run serverpod create mypod. You can obviously name the project anything you want. This is just an example. The create command will set up all necessary files and folders of your project. If you go into your new project directory, you will see that ServerPod created 3 different Dart packages. mypod client contains code you can use to communicate with the server. This code is generated, so you will typically not need to change anything in here. In the mypod Flutter package, you will find your Flutter app. The Flutter app imports the client package and contains a Hello World app to get you started. Finally, you have the mypod server package. This contains your server code. This is where you add your models, endpoints, and methods. ServerPod automatically analyzes the code in your server to do all the grunt work of building the API. When you add a method to the server, it will be replicated in the client. So when you call it from your Flutter app, it will be just like calling a local method. It really is this simple. To start the server, change the directory to mypod server. Start your Docker container for running Postgres by running docker compose app --build --detach. Next, run dart bin/main.dart --apply migrations. This command will start the server and all the default tables to the database. ServerPod comes with a set of tables to handle things like future calls, logging, and health checks. ServerPod is now alive and ready. You will know that everything is working when you see a confirmation on your terminal displaying the ServerPod version, listening ports, and the mode it is running in. Now, let's see some action. It's time to launch the demo app. Start the default demo app by changing directory into the Flutter package, mypod flutter, and run flutter run -d Chrome. You can run it on any platform supported by Flutter, of course, but know that if you're running on macOS, you must add permissions to connect to a server in your Xcode project. That's very cool. You now have ServerPod up and running. Let's take a look at the structure of your server. You will need to keep track of only a few important directories. In the config directory, you will find the configuration files for your ServerPod. It contains different configurations for running your server in different environments like development, staging, and production. By default, ServerPod will start in development mode when you run it locally on your computer. In the config directory, you will also find a password file. It contains the secrets required to connect to your database and any other services. In the endpoints directory, you place your server's endpoints. You can add methods to your endpoints, and ServerPod will automatically generate the corresponding methods in your client. In the models directory, you place your model definition files. You write the model definitions in very simple YAML, and ServerPod will generate the Dart code, including serialization, mappings to the database, and everything else. The generated models will be available on both the client and the server. And that's it. Those are all the places you will need to know about to get your server going. Whenever you change your code in either the endpoints or the models directory, you will need to regenerate the classes managed by ServerPod. You do that by running ServerPod generate in your server directory. You can also pass the watch flag to ServerPod generate to continuously generate files whenever you edit your models or endpoints. Next, let's talk about endpoints. Endpoints are the connection points to the server from the client. With ServerPod, you add methods to your endpoint, and the corresponding client code will be automatically generated. ServerPod builds a well-formed REST API for you, but you will never need to really touch the code. For the endpoints to be generated, you will need to place them in the libsource endpoints directory, and they need to extend the endpoint class. The server methods you add to the endpoint must return a typed future, and the first parameter must be a session object. The session object holds information about the call being made and provides access to the database, caching, and other of ServerPod's features. This is an example of an endpoint called example. It's good practice to include the endpoint suffix in the name of your endpoint, but the code generator will remove it, and you will refer to the endpoint as just example. The endpoint contains a single method called hello. Note that it returns a typed future, and that its first parameter is the session object. This will tell ServerPod that this is a method that should be included as part of our API and in our generated client. Whenever we change the code in the endpoint, we must run ServerPod generate to update our generated code. After you run ServerPod generate, we can call the server methods from our Flutter app just as if it were a local method. In this example, we access the hello method of the example endpoint, pass a string to it, and then wait for the result. The result will be hello world. Easy as that. Now, let's look at how we can create data models and serialize data. ServerPod defines models in YAML files and then generates Dart classes from them. Place your models in the libsource models directory, then run ServerPod generate to make the models accessible to the client and to the server. This is a simple example of a YAML file defining a model. Serverpod supports serialization of most of the basic Dart types, including booleans, integers, doubles, strings, datetimes, and byte data. You can also add lists and maps. If you add a list or a map, it must be typed with a type supported by Serverpod. Null safety is also supported. Once your models are generated, you can use them as parameters or return types in your endpoint methods. You can also use other models as types in your model file. This works for maps and lists too. The cool part with the model files is that they are very quick to write and easy to read. But there will be loads of Dart code generated that you don't really need to care much about. This is how your model shows up in your code. It's just like any Dart class. It has a constructor with all the fields specified in your model. Non-nullable fields are required and nullable ones are optional. You can access the fields as properties, just like you would expect, but you also have access to a copy-with method. What's really sweet about the model files is that they can be mapped to the database using Serverpod's Object Relation Mapping, or ORM. This makes it easy to store and retrieve objects. Just add a table keyword to your model file to bind a model to the database. The value of the table key is the name of the database table. For this to work, we must add the table to our database. Thanks to the database migrations, it's easy to do with Serverpod. Whenever you make changes to model files that contain a link to a table, you will need to create and apply a database migration. A migration is a set of SQL queries that updates the database schema while still preserving the data in the database. If you have made changes to your model files that require the database to be updated, you run serverpod create migration. Serverpod will compare the last definition of the database to the current state in the model files and generate SQL code that will change the schema to reflect the changes. You can now apply the migrations by passing the apply migrations flag when starting the server. In this example, we are also using Serverpod's maintenance role. This will immediately shut down the server after the migrations have been applied. This can be useful if you are running migrations as part of continuous deployments. After the migrations are applied, your database is up to date. When you add a database table to your model, Serverpod will add a static DB field to the generated class. The DB field gives access to several methods for working with the database. For instance, if you want to insert an object into the database, you use the insertRow method. When working with Serverpod, every table has an ID column, a unique object identifier when stored in the database. Inserting an object will return a copy with the ID field set to the row's ID number. After an object has been inserted into the database, you can retrieve it using the set of find methods available in the generated class. For instance, you can find a single object by its ID by using the findById method and pass it the ID of the row. You can also use expressions to do more refined searches. In the findFirstRow method, the where parameter is a typed expression builder. The builder's parameter, named company in this example, contains a table description which gives access to the table's columns. Here, we find the first row where the company's name matches the string my company. We use a builder method to construct the queries because it allows the complete expressions to be type safe. So you can use your editor's autocomplete to find the names of the column names of your table. Working with the database is an extensive subject, but Serverpod makes it so much easier. To learn more, I recommend that you have a look at our documentation. It covers things like working with relations and doing advanced queries. Before we wrap this up, I just wanted to share a few more tips and tricks on what you can do with the Serverpod models. There are some really neat things you can do. First, In your model file, you can switch out the class keyword for exception. By doing this, ServerPod will generate a special type of exception for you. This means that you can store the exception in your database if you need to. And you can also pass it over the API. You do this by throwing an exception on the server. The exception will be serialized, sent to the client, unpackaged in your app, and rethrown there. This is great for handling errors you want to notify the client about. For security reasons, only exceptions for which you have created model will be passed to the client. If any other exception occurs, the server will not reveal any of that information to the client. Instead, the exceptions get logged, so you have a chance to correct them in your code. Next, ServerPod has support for models based on enums. Switch out the class key for enum and provide a list of values. It's highly recommended that you also set a serialized key to by name, which will save the values as string instead of numbers. You can include your enums as part of other models or pass them as parameters to your methods. Just like you can document Dart methods with DartDoc, you can document your model files. But instead of using the triple slashes as you do in Dart, you use triple hashes in ServerPod model files. The comments that you add here will be included in the generated code, which means that you will get access to the documentation in your editor or if you publish your code. As always, it's also good practice to document your code for other developers who may need to dive into it. That is what I had for you today. Getting started with server-side Dart is fun and easy with ServerPod, and I hope I inspired you to start playing around with it. To learn more, visit serverpod.dev. You'll find more tutorials and documentation there. We also have a vibrant community on GitHub, so it's quick to get any of your questions answered there. Till next time, happy coding!